today we are going to be considering a question in physics practical, and basically we are going to be considering electrical practical in physics. And the question before us is: a student investigates variation of the current I. So a student investigates the variation of the current I. So the experiment was all about the variation of current I through a filament bulb for a range of different values of potential difference V. So, and then after this experiment of variation of I through a filament bulb have been carried out, values of V, which is the potential difference, was obtained, and the following data was recorded. We can see the potential difference in volts, and then we can see the current in milliampere. So at 1 volt we have 25 milliampere. At 2 volts we have what? 47 watt milliampere. At 3 volts we have 68 milliampere, and that's it. So the question says, Roman figure 1, draw a circuit diagram for the experiment. We have to draw a circuit diagram for this experiment to be carried out. So to Roman figure 1, draw the circuit what? Diagram. And how do you do a circuit diagram? Follow me, please. We are told that the experiment was carried out by passing I through a filament bulb. So meaning we are going to have a filament bulb. We are going to have an ammeter for measuring current I, and then we are going to have a voltmeter for measuring what? Value of potential difference. So these are the apparatus we are going to need for this experiment. The apparatus are as follows. We have number 1, to draw a circuit, we need, or to set up a circuit, we need the source of current, which is DC here. In this case, it is direct current, not an alternating current, it is direct current because we are using a small amount of current. So we are going to be using what? The battery as our direct source of current. So, and how do you represent battery here? We are going to have a small line and a big line. Okay, let me draw that very well. Small line and a bigger line beside. Then there is a hyphen that separates them, and then another small line. So we have positive, we have negative, positive. Let me draw it very well so that you can see. So we have small line, then so we have minus, plus, minus, plus. So that's that for the battery. So we have the battery, which is the source. So now it's connected to ammeter, which measure the electric current, and then we're going to have trying to draw our circuit now. So we are going to have our switch here, which is key. We can also be called key. Switch is just one that this is an open key. Now we have not closed the circuit. You have not even set up circuit already. We have not even finished setting up our circuit, but this is the key, or we call it switch. This point here is the key or switch. So let me just label it the switch, or it is called key. This is the battery. This is battery because it has 2 cells. Every battery has 2 cells. It has negative plus. This is 1 cell. Negative plus. This is another cell. So that is battery. So this is an ammeter for measuring current I. This is used for measuring current I. This is used for measuring current. So let's continue to draw our circuits. So to draw our circuits, so we have this. So here I'm going to be connecting my voltmeter in parallel to the filament bulb. This is voltmeter here. So I will tell you how it is being done in practical. So here we have filament bulb being attached in parallel to the voltmeter. So I'm going to draw a filament bulb here. Okay, so notice this point. It is called the point whereby it's parallel. So this point where it is being called. So we are going to have a variable resistor. Variable resistor is needed here. Variable resistor is needed here. The variable resistor is needed here, which is represented by a box, rectangle, and a arrow. So it's a variable resistor, or we call it what? Rheostat. This is a rheostat or variable resistor. Rheostat can be rheostat or variable resistor. So or variable resistor is better. So now, so this filament bulb, why is it called filament bulb? Let me show you something. There is a wire inside this bulb that make it filament, a curly wire. So in this bulb there's a curly wire. So this curly wire is one that is called filament. When this is connected to electricity, this filament the temperature of the filament will increase and it will produce heat. And as it produces heat, As it produces heat, it gives off light. So that's why it's called filament. That filament is made of a coily metal. So, and because of that coily metal inside, that's why we call it what filament bulb. So that's the circuits that we have to construct. But I want you to know something here, that the voltmeter here is connected in parallel. That is, they are in T junction. Look at this. There's this wire. The wire that is coming from, this is the wire that is coming from the left hand side of the what, of the filament, and the wire that is coming from the right hand side of the filament bulb is connected to the what, to the wire coming from the voltmeter, and to the wire coming from the what. Look at this. Look at this wire. I'm going to. This is wire one from the switch. This wire two from the voltmeter, and this wire three from the what, filament. Wire one, two, three. They connect at a junction T. Junction T. So that's why it is parallel. So whenever we have something like this, it's called parallel connection. Parallel connection. So this is called parallel connection. This is a parallel connection. So there's a parallel connection between the filament bulb and the voltmeter. This is parallel connection. Connection. So it's very, very important that you know that this is a parallel connection. So now, why the voltmeter and this resistor are in why the voltmeter, this is the, sorry, why this ammeter here, this ammeter, this the ammeter, the wire coming, the conductor, the metallic conductor, which is the wire coming from the ammeter to this point, they are in series. It is only what, they are connected together. So it is series. This is series connection. This is just only one wire connect them together, or I say just one wire. There's no junction. So this is series connection. Series connection. So the ammeter and this resistor or variable resistor are in series connection. Even with what, with this are in series connection. This one, two, and then three. They are also in series connection. They're also in series connection. So these are series connections. So you need to know that the one that are in series connection, the one that are in what, in parallel connections, for you to get the what experiment. So these are the circuit. This is all the circuit for the experiment. You know, this is voltmeter, this is filament bulb, and this one is rheostat. So now that's the electric circuit for the question. So now let's quickly go to the next one. I'm planning this one up now. So let me make it big. Okay. So taking my, so we are asked to, what's the next question? Draw a suitable graph. Look at a suitable graph on a graph paper to show the relationship between voltage and then current. That is potential difference and then current. We have to show the relationship between what, potential difference and then current. Potential difference and then current. So how do you do that? We have to draw a suitable graph on a graph paper to show the relationship between potential difference V and the current I. So graph of potential difference V against current I. So we are to draw a graph of potential difference V against I. And so the first thing is to title the graph first, and the next thing is to choose your scale. What are the scales that I need for this experiment? And we can see that for these values we have 1 to 7. The maximum value for potential difference here is 7. So we are having value of 1 to 7. So we're going to consider the scale that we get to 7 for potential difference V. So for me to choose a suitable scale for this graph work, I have to choose a scale that will suit 7, and at the same time it will also enable me to actually be able to locate all this number 1 to 7. So what I'm going to do is that if I count all the boxes that I'm having on the vertical side, because this V here is going to be on the vertical side and this I is going to be on the horizontal side. So look at the number of boxes we have on the vertical side. You can see if I start from this point here, let's say this one is 0, this is my point 0. So did I have 1 to 7 here? 1, 2, 3, 4, 5, 6, 7. So what I'm going to do is that if I make this one my 0 now, so I have another 1 to 7 boxes. I can make it up to 7. So what I'm doing now is that I'm representing each of the big box by 1, by increasing 1. So 1, 2, 3, 4, 5, 6, and then what? You can see 7. So what I'm doing now is the scale now here is saying that for voltage axis, 2 centimeter represent 1 volt, 1 volt on V axis. That's what it means. So 2 centimeter represent 1 volt on V axis. But for the what? For the current axis, let's see the current axis. The highest value I have for current axis here is 104. So I must choose a scale that will get 104, and at the same time give me a very reasonable point when I'm locating all these individual points like 191. So now what I'm going to do is that if I count how many boxes I'm having the result starting from this as 0, 1, 2, 3, 4, 5, 6. So I'm having 6 and 7. That is, if I use 20 times 0 will give me 140, which is enough to cover 104. So what I'm going to do is that I'm going to say, okay, let me say 2 centimeter represents 20, this is 30, this is going to be 40, this is going to be 60, this is going to be 80, this is going to be 100, this is going to be 120, and this is going to be 140. It's going to be 140. So these are the values here that I choose for this. So for this one, it's going to be 2 centimeter. Let me use another color for us to see the difference. So this is going to be 2 centimeter represent 20 milliamps on I-axis. So that's that for that. So in order to plot my graph now, I'm going to look at the first value I'm having here. I'm having 1 and I'm having what? 25. So this is 1. And where is my 25 going to be located here? Now to know where this is my 1 here, look at this. This is 1 here. And so you trade this one, and 25 is going to be what? This is 1 here, it's on this line. So but 25 is going to be in between 20 and 40. And that comes to this smaller box. So what does this smaller box represent? So you said, okay, I have 10 boxes in between 20 and 40. In between 20 and 40, I have 10 boxes, right? 20 divided by 40 is going to give me what? Sorry, 20 divided by 10 is going to give me 2. I'll come again. Like my unit, my scale for the horizontal axis, which is I-axis, is 2 centimeters that represent 20, right? So 20 divided by 10, where I get this 10 is the 10 box that is in between 20 and 40. So 20 divided by 10 boxes, so it means it's going to give me 2. So need that individual boxes, individual small boxes between 20 and 40 is going to be 2. So this is going to be the first box immediately after 20. The first smaller box immediately after 20 is going to be 2. So 2 plus 20 is going to be 22. So 22, 24. So between 24 and 26, we are going to have 25. So in between that box, we are going to have 25. So I'm going to locate 1 and 25 in that direction. 1 and 25 is going to be here. So 1 and 25 is there. So 1 and 25, that's it. It's purely, you're not seeing very well. Let me just give it red, because red color seems to be showing very well. So I'm going with red now. So that's my point. So the next one is I've successfully located my 1 and 25. The next one is 2 and 47. So this is 2 here. And 47 is going to be in between 40 and 7 and 40 and 60. So this is going to be 42, 44, 46, and then 48. So we're having 40. That is in between. So this is 46, right? So I'm gonna have, so that's 47, 42, 43, 44, 46, 47. So the next one is 368, 3 and 68. So we have 3, then 68, 62, 64, 66, 68. So that's that about. So that is 368, 480, 4, and then 80. So this is going to be here. So that's that. So the next one is going to be 591. 591. This is 5, and this seems to be 90 here. 90 is going to be, this is 82, 84, 86, 88, 90. So 91. So we have 91 in between. So that's that. 591, and the next one is 600. 600 is going to be here, and the last one, which is 120, 104, and then 7. This is 7 here at the end here, 7 here. Oh, but it's 104, not. So we have 107 at 104, 7 and 104, 7 and 104. So we are going to have 102, 104. So we have that. So those are the points. If you follow, you see that those are the points. Now, if you are to draw this graph, you have to connect this point together. This point that you see on your screen, you have to connect all those red points together. You won't get a straight line graph. It's actually a curve graph, not a straight line graph. So because you are using a filament bulb, and that's the implication here, assuming we are using another conductor bulb, the apparatus or one of the materials we are using here for this circuit is filament bulb, and it has an implication on this experiment. So that's why we're going to have a curve as our slope, something like curve. So I'm going to connect this with a blue pen so that we can see it. So this is my starting point, this is my first point. Hopefully you'll be able to follow me. This is a freehand curve, so it might not be as perfect as expected, but it's going to be manageable. So let me draw the hand finish very well. Okay, so we have, so that's that about that. Just want to make sure that we have a good can a little bit clean this space and then join it together very well. So how do you do that? You can take a connect this very well together with this so that you have a perfect curve. So that's it. So I'll show my point very well so that you can see it. So these are point, these are points here, these are points here, and these are points here. So see, if you draw it very well, take everything of our points, nothing is left out. So this is another point here, so you can see it. That's why I'm emphasizing on it. So now, so that's the curve that we have, that's the slope. So that's the curve. Anyway, there's no slope here. So you can still calculate slope. If you have to calculate slope here, you can still calculate your slope. You just have to pick one point and then you draw the line through it and find the tangent of the curve. The only thing you can draw is draw a line at one point of the tangent, and then you calculate your slope from that point. But you are not asked to calculate the slope anyway. So now let's go to the next question. Let's go to the next question. So the next question here is does this graph shows that Ohm's law is obeyed for the filament bulb? Justify your answer. Now, does this graph shows Ohm's law? Nope. So no, the graph does not show Ohm's law. Why? Because it does not obey Ohm's law. No, graph does not obey Ohm's law. The graph does not shows Ohm's law. Then we are asked to justify this answer. We have to justify this answer. So how do you justify the answer? The fact that it's not showing Ohm's law or it does not obey Ohm's law? Because number one, we have a curve rather than a straight line. So it's not a straight line graph. It's not a straight line what? Straight line graph. Because Ohm's law say that at constant temperature and pressure, the potential difference across a metallic conductor is directly proportional. It's directly proportional. It's directly proportional to the current. So the potential difference is supposed to be directly proportional to what? To the current at constant temperature and pressure, and it's going to give us what? A constant of proportionality of R. So which is Ri. That's why we get V equal to what? I R as Ohm's law, where this R is the constant that we're talking about, the proportionality constant. Apart from other factors like temperature and pressure, the proportionality constant we're talking about here is R. So at constant temperature and pressure, the potential difference of a metallic conductor is directly proportional to the current. Where when you carry out the mathematical expression of that relationship, you're going to have your proportionality constant to be R, so which is the resistance. And then in this case, we don't have straight line graph. And if you don't have straight line graph, meaning that we don't have our resistance to be constant. So that's why it does not obey Ohm's law. So Ohm's law is not obeyed because we don't have straight line graph. And because we don't have straight line graph, we don't have constant resistance. So meaning that our resistance is not constant. So resistance is not constant. It's not constant. And it's justified our diagram because we use a rheostat, a variable resistor. Use a variable resistor. So to calculate our current. So that's it. So the straight line is not, the graph is not straight line graph, and the resistance is not constant. So these are the two justification. So and then maybe you cannot calculate the gradient easily from the curve. You can only calculate the tangent. So that's another third point. You cannot calculate the slope. We can only calculate the tangent of the curve. So now, so those are the things that you need to note. Number 3, we cannot get the slope. We cannot get the slope. So slope cannot be calculated. Slope cannot be deduced. Slope cannot be what? Deduced. Cannot be deduced. But if they want to calculate gradient, we can calculate gradient. So slope cannot be deduced. So these are the things that you need to know. So these are the things about that question. So we'll move to another questions. And the next question is, let me clean this. The next question says, calculate the resistance of the filament bulb when the current is this. So when the current is 40 ohms, what is the resistance? So from the law of Ohm's law, which says V equal to what? IR. So we have been given that we should calculate, we are saying we should calculate what? The resistance R. But we are given current to be what? 40 milliamp, but we don't know voltage as well. So voltage can be deduced from the graph. All you just need to do is just to trace this to 40. So you trace this. This is your 40 here. The 40 is meeting at this point here. 40 is meeting the graph at this point. You can see the line 40 meeting this graph at this point here. So you trace it down to where you have, you trace this line down to where you have this. So what do you have? When you trace it down, trace this line here down to the current side. The current side, so we have this equivalent point. Okay, I'm right. This equivalent point of this. So if this is 1.1, 1.2, 1.3, 1.4, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. So your voltage is 1.6 volts. So at 40 we have what? At 40 milliampere we have 1.6 volts. So it's okay. So we can now convert this milliampere. We cannot be used like this because we're looking for resistance. Resistance would be what? V over V divided by what? I. So but you need to convert this I to ampere, which is ampere. So divided by 1000. So 40 divided by 1000. To leave it, to remove this milli, divide by 1000. So we have 0.04 ampere. So we have 0.04 ampere. So we have gotten your current to be 0.04 ampere. So 1.6 divided by 0.04 ampere. So when you use your calculator, your current should be what? Let me quickly grab this calculator. Should be 1.6 divided by 0.04. 0.04 is going to be 40 ohm. So we have 40 ohms here. And then the next one is where we have 90 ohm. The same thing, just go to here, locate your 90. This is your 90 here. I have 90 to be 82, 84, 85, 86, 88, 88, 90. This is supposed to be 90. So you throw up, this is your 90 here. Yeah, very close to this. This is your 91 here, you can see. So your 90, don't forget there's a point here by 91. I almost even don't show that one. I show you, but it's not clear enough. There's a point here on 91. So don't forget there's a point here on 91. I put it there, I just want to emphasize on it. So there's a point here already. So just this is where your 90 is. Your 90 here is almost corresponding to this. Your 90, this 91. So 90 is gonna be around here. So that's 90. What to use another that color for you. So 91, this is 91, this is 90 here. So when you touch 90 at this point, this is your 90 at this point, and then you trace it, this is your 90 at this point, you trace it back. It's almost giving you 5 volts. It's almost giving you 5 volts, right? 5 volts. So it's almost giving you 5 volts or 4.9, but this is actually, if I trace it back, this is, I'm getting my 90 to be around this point. So this is my 90. So 90, this 90, you trace it to the what? To the vertical. I trace this 90 here, up here, go there. See? Let me see. If I trace it up, trace it up, trace it up. Okay, I have it here. I have it here. Sorry about that. Let me clean it up. So now, if I trace this 90 up and I trace it to touch the line, I have it here. So it is around. I have it to touch this. You can touch. I trace 90 here, touch this line. So you trace when you touch this line, you trace it, trace this line here. You trace it to what I mean by trace. You trace it to this point here. It give you 4.9. This is 4.9 on the graph. While this is 90 here. This is 90 milliampere, and this is what? This is 4 volts here, and this is 90 milliampere. The same thing happens to the 40 I did the other time. So when you trace it up, this is going to be what? The 40 milliampere, and this is going to be your 1.6 volts. So don't forget, this one is 40 milliampere. So the same thing that we did here, that's what we did here. So for here we have this. So we have 4.9. So for the second one, which is 90 milliampere, 90 milliampere, we divide by 1000. We're going to get 0.9 ampere. So we have your volt, as you can see, is equal to 4.9 volts. So the resistance will be volt over I, which is equal to 4.9 divided by 0.09. 4.9 divided by 0.09. 09. So we have R to be 54.4 ohms. So that's it, approximately 54.4 ohms. So that's that about that for the calculation question. So let's move to the last questions. Okay, let's move to the last questions. So what's the last question saying? What happens to the resistance if the filament bulb has current? When the filament bulb as the current increases, what happens to the resistance of the filament bulb as the current increases? What happens to the filament bulb as the current increases? I come again. The next question says, explain what happens to the resistance of the filament bulb as the current increases. What happens to the resistance of the filament bulb as the current increases? So what we are going to do is that, okay, let's draw the filament bulb itself. This is the filament bulb, right? Just take this for instance. The diagram is not that good, so but manage it. So we have filament bulb here. Okay, so it's better. So and then when you have filament bulb, and then there is a coily. This is what we call filament. This is filament. Now, what happens is that when you connect this is the positive side, and then we have the negative side black. Just trying to make this the negative side. This is the positive side. So when you connect wire to both sides, this is negative terminal, the positive terminal. When you connect electric current to this side, this is wire, and then what you are asked is that when the electric current that is inside this, when the electric current that is coming into this, when the electric current I that is coming to this is increased, when the electric current that is coming to this is increased, assuming you increase this electric current, what will happen to the resistance? What happens is this: when you increase the electric current that is coming into this, filament. What happens is that this gets it up. When you increase the current I of the filament bulb, this is increased. What happens to the temperature? The temperature will be increased as well. The temperature will be increased. This thing will start to what? To get heated, because this is a metallic. Whenever you increase the current, it gets heat. The temperature, whenever you increase in current, the temperature increases, the heat energy increases, the heat energy increases. And when the heat energy increases, the current, what happens is that the flow of ions, which is the electrons, the flow of the electrons, that's why I put E minus, it is electric energy. So the flow of electrons increases as well. And because there is a flow of increase of electrons, definitely the resistance, because this will cause conjection. There's going to be electrons everywhere. Electrons, and they're nowhere to go out. Because the temperature is increased, the heat energy is increased, there is flow of electrons everywhere. And then the resistance, there will be much resistance because they are not flowing out. This is a barrier here. They will not be able to go out, they'll be around this place. But there's going to be resistance. The resistance is going to be increased as well. So increase in current will lead to increase in resistance. Now explain why. The temperature is increased, the heat energy is increased, and there is what? Conjection of what? Electrons. So that's why the resistance will be increased as well. So that's that about our come to the end of the lesson.